Welcome to Chaos Orchestra episode 4, the Science Knowledge Graph. Science is the key pillar of social progress, and still scientific knowledge continues to be confined to documents with unstructured text, seemingly inseparable from the medium. The TIB at the University of Hannover even compares it to hieroglyphs carved in stone. A scientist on average reads about 250 papers per year, but not only more and more of the scientific papers appear to be irreproducible or redundant, but also scientists derive their hypotheses from a smaller and smaller fraction of our collective knowledge, and consequently asking the wrong questions or asking questions that have already been asked. And although chance has always been a factor in scientific discovery, it currently is playing a much larger role than it should. It seems like science has outgrown the human mind and its limited capabilities. One promising strategy to overcome this problem is to integrate machines and artificial intelligence in the scientific process. Machines obviously have a greater memory and higher computational capabilities than the human brain. The automation of the scientific process could greatly increase the rate and efficiency of scientific discovery. It could even begin a scientific revolution. But this leads to a question: can scientific discovery at least be partly automated? The TIB at the University of Hannover aims to build a science knowledge graph that would contain all the scientific knowledge and one day maybe even be able to reason and deduce new knowledge from it. But how will such a knowledge graph look like? And will we be able to interact with it through a highly intelligent search engine that finds scientific results and maybe even deduces research gaps? Today, I'm honored to interview Professor Sören Auer, the Director and Head of Research for Data Science and Digital Libraries at the TIB in Hannover. Professor Auer was a pioneer in the semantic web movement and focused his research on semantic technologies, knowledge engineering, and information systems. I hope you enjoy the conversation as much as I did. What is your vision on the science knowledge graph?
Science is about knowledge, right? So we want to generate knowledge about the world, about various different aspects and different disciplines. And currently, this knowledge is stored or represented in static PDF articles, and that makes it extremely cumbersome actually to discover answers to research questions. And that's why we want to build a knowledge graph for scientific contributions, for scientific results, which gives basically an overview of the current state of knowledge in various scientific disciplines. And a bit maybe like Wikipedia, meanwhile, became a knowledge base covering all kinds of encyclopedic knowledge, and we can find out about all different topics, what yeah, get information about them. There's also Wikidata, a knowledge graph for Wikipedia, which basically represents such factual knowledge about cities, organizations, all kinds of different entities which are discussed in Wikipedia. And we need something like this for science. Of course, it's incredibly more difficult because in science we usually don't have so clearly identified entities. Yeah, in encyclopedic knowledge graphs, we have people, we have organizations, we have certain historic events, and they are very clearly defined or relatively clearly defined. Of course, there are also sometimes debates and discussions, but that makes it a bit easier for encyclopedic knowledge to represent in a knowledge graph. In science, usually it's very dynamic because in the beginning we don't know yet whether a certain theory, for example, holds or how to define the concepts. Only in the scientific discourse, basically, we establish more clarity about these concepts and the relationships, and that's why it's more challenging on the one hand. On the other hand, I think we need something to represent the scientific knowledge.
How much knowledge are you actually trying to represent in machine readable way, and how much will stay in natural language?
That's a very interesting, important question, which I also cannot precisely answer. But basically, what you build a knowledge graph for answering questions most of the time, yeah. And for question answering, or conversational AI is one important topic. Many of us are used to use services like Amazon's Alexa or Google Now, where we can ask questions, and those questions are answered using structured, organized knowledge. And the same we want to provide for science, that you can actually ask a question, for example, what is the basic reproduction rate of the coronavirus, and then you get an answer. And currently, you actually, in order to answer such a question, you have to read hundreds of papers or dozens of papers, and then maybe you're able to answer this question. So basically, we want to a bit represent information on such a level of granularity which allows researchers to answer certain questions. And of course, there can be more specific questions. For that, you need more fine-grained and more detailed descriptions. But first, we want to start maybe with more, yeah, um, coarse-grained or general questions. For example, in computer science, also what is the performance of a certain algorithm, but how the algorithm is actually implemented in details, that's maybe still described then in the scientific paper. But I think this will be also not a strict um, border, but as we go, basically we will progress and represent more information in the knowledge graph. We start maybe with relatively superficial information, and then step by step, the more researchers use the knowledge graph, the more we want to also proceed to more detailed information. But that's an experiment. I think no one has yet built such a knowledge graph for science. So we have to see how this experiment evolves and how it goes.
So science is all about nuances, right? Small details can make a huge difference. And we have in knowledge graphs, we have this challenge of the semantic gap. So it's really hard to represent actual knowledge as precise as with natural language, because natural language is just extremely expressive. So how do you deal with these details and this circumstances under which some answers might be true or not?
Basically, the idea is the same like with encyclopedic knowledge graphs. So we basically want to represent certain facts and statements and organize these statements in a bit larger chunks. For example, a research contribution would be a bit a larger chunk of information, and then you have a description basically of this research contribution. And of course, this also might evolve over time. The more the scientific progress evolves, and the semantic representations might change. Um, but you're perfectly right that it might not be possible to maybe represent all the details easily in such a knowledge graph. That's why we want to initially focus a bit on more coarse granular descriptions, but already this will give a tremendous value. For example, the example I gave you, the basic reproduction rate of COVID-19, yeah, it's a relatively clear a research question, and you can quite easily describe what different studies, what statements they make, what basic reproduction rate they assume to be to hold, also under which circumstances, in what time frame, in what geographical region, for example, maybe also related to what kind of mutation which we currently observe. And this can be easily represented in facts. How they exactly measure that, what approach they use to determine the basic reproduction rate, that is something which requires really a longer description, how they design the study and so on. And probably this information is well described still in a natural language article. But we researchers need to find information. We are dealing with this information overload paradox. Yeah, we have millions of publications which are published, and even in small and relatively narrow research areas, it's very difficult to keep up with the flood basically of publications there, and already organizing them a bit more and describing which contribution is made in which scientific article, that will help researchers already a lot to basically master this flood of information.
Mhm. Can you maybe give a few more example questions that researchers will be able to ask to boost their own research?
Sure, yeah. For example, um, also a question we are working on are climate models, representing there are different models, how the climate change will evolve in the next years. And these different models, they are working with different assumptions. And so we also represent this information, for example, in such a knowledge graph, so that you can get an overview basically of the different models for modeling the climate change, and then also on the prerequisites, on the parameters of these models, and then you get a better overview, maybe why a certain model came to a certain conclusion. You can then more easily get an overview, but you can basically apply this concept to many different scientific disciplines in material science, where it's about the characteristics of different materials. Of course, you have a lot of experiments described in individual papers about a certain material, what properties and characteristics it has under certain circumstances, like air pressure, like temperature. And in order to get an overview on the characteristics of a material, you have to basically combine the knowledge from dozens or sometimes hundreds of publications. And that's what we want to represent in the knowledge graph, basically. Maybe a bit less this procedural knowledge, how a certain experiment was done or a certain simulation, but more descriptive, describing what the conclusion, what the results are. And that allows you to basically drill down into the scientific knowledge, answer certain initial questions, and then when you have more detailed ones, of course, you need to read the full text of the scientific publication.
Mhm. So, given the complexity of these publications, it sounds extremely difficult to be able to aggregate this knowledge or the results from the different publications. How do you do that?
Actually intertwine automatic approaches and crowdsourcing. So the problem is a bit fully automatic approaches. They work when you have a lot of training data, usually like artificial intelligence, for example, requires training data. And the problem we face is we don't have much training data because there is no scientific knowledge graph. Of course, there are a number of knowledge graphs focusing on bibliographic information on publications and authors of publications and citations maybe, but we want to go a bit deeper into describing the scientific publications semantically, the contributions made in the scientific publications. And for that, we initially at least don't have training data. So there we rely on crowdsourcing. So researchers basically have to populate the knowledge graph manually. And that's, of course, a challenge. How can we get researchers to do this work? So we think about how to give them incentives or instant benefits, so that, of course, once they represented their scientific contribution in the knowledge graph, they can also see how it compares with other scientific contributions, related ones, and how what their contribution to the state of the art is. And that, of course, helps researchers maybe to master the peer review process better, because that's what peer reviewers assess: what is the contribution, the actual contribution of a certain work. And by representing that in the knowledge graph, you can first then include it also in your publication. You give peer reviewers a better overview of what you have done and how it yeah, juxtaposes with other contributions, and that generates some insights for you yourself, but also for peer reviewers and stakeholders, users of your research, so that in the medium and long term you will benefit of adding such information to such an open research knowledge graph. And of course, the more data we have, the more information, the more we want to also implement automatic techniques. We actually already started now, so that basically you get some suggestions how to describe your research paper, that you don't have to start from scratch, but you can already use existing templates, for example, or you can describe it similar to an approach which is already described in the open research knowledge graph, to provide you with a framework in a way which you then can fill out. Yeah.
So, just to get a feeling for that, how big is such a knowledge graph per paper? So, if I'm a researcher, how many concepts, links, and
Yeah.
notes do I have to draw?
Um, it actually can be relatively small. For example, this COVID-19 example, which I gave you, the basic reproduction rate, it's basically four, five, six triples which are important. Yeah. So what is the basic reproduction rate you determined in your study? When have you done your study? In what time frame? Because that's also important. Were there some non-pharmaceutical interventions in place? Where did you do it? Because cultural aspects also play a role. So these three, four facts play an important role there. And these are basically three, four triples which you add to the knowledge graph. And they provide already, I would say, a tremendous value because we actually found more than 30 studies determining the basic reproduction rate. Each of these studies has 10, 15, 20 pages. You can imagine you have to read hundreds of pages in order to answer the research question, what is the basic reproduction rate? In our open research knowledge graph, you get an overview. You can see it as a tabular overview, which summarizes basically these base facts from these publications. And that already lets you basically answer this research question with the tip of your finger. You can also create chart visualizations and various kind of analysis on top of that. But I think the description can be relatively small. Of course, you need to have a certain competency question in mind. What would you like to answer? Yeah, but that also I think helps researchers when they write a paper, when they contribute. They of course should determine what is their actual contribution and how does it compare with others, and this a bit defines then how the description of the contribution should look like in the open research knowledge graph.
So this manual approaches with some small key facts about the publication will already contribute huge value to the science knowledge graph. Now you talked about this automated approaches, and most natural language extraction algorithms can use knowledge graphs as blueprints to extract knowledge from text, right? So wouldn't it be possible to let the domain expert or the author of the paper create something like a blueprint about his paper, and based on that create an automated knowledge extraction out of it?
Yeah, we are working on that, but the challenge is that these automatic extraction methods, so there are basically two things what you need. One is a named entity recognition. So in the text, you need to recognize what are the entities which are discussed in the text. And then you need to determine their relationships, the relationship between these named entities. So named entity recognition maybe is relatively easy, especially when you are searching for some specific entities, when you search for materials, for example, or for genes in life science publications, for diseases, for symptoms. Then you can have a relatively high precision and recall for this named entity recognition, maybe 70, 80%, in some cases, maybe even 90%. Much more challenging is to discover the relationships between these entities. And there, the precision and recall dramatically drops. I think you reach rarely above 30, 40%. That basically means that two-thirds of the relationships are either wrong or you haven't found them. Yeah. Also, as I said, many relationships, if you look at the scientific study, you have like 10, 20 pages. Many of the relationships which are in there are maybe not so interesting from an knowledge organization point of view. They are interesting when you are really interested in this particular approach, but not when you want to see different approaches, maybe in a comparison. Or so some of these relationships are more important than others, and determining which ones are more important than others is also incredibly difficult. You need a lot of background knowledge. You maybe also need to have these competency questions in mind. So that's why my assessment is that natural language processing will not be able quickly to populate such a knowledge graph. But of course, it can assist, for example, and it can help. So what we are working on is, for example, defining templates for certain research questions. And once you have a template, then when you have a new publication which aims to answer this research question, you can maybe determine that this template might be suitable for describing this particular paper. And then you can also suggest certain values to populate the template with. And then the researcher just has to accept or reject those suggestions. So that's a bit how we want to split this process into smaller steps where we intertwine this machine intelligence with the human intelligence to, in the end, reach the precision and recall which we need to have really high quality knowledge graph, because I think it also doesn't help researchers if there is a knowledge graph but a lot of the information is wrong or not properly represented, so it needs to have a certain quality to be acceptable. It doesn't have to be 100%, but I would say 80, 90% should be correct there. And that's also a bit what we see in other knowledge graphs. If you look at Wikidata, Wikipedia, or OpenStreetMaps, of course, not everything there is correct, but a large share is correct. And they also manage these projects to involve crowdsourcing to a large extent, and that's a bit what we follow. I want to follow here as well.
So your target here with crowdsourcing is basically to provide the researchers all the tools and recommendations that make it very easy for them to represent their part of this knowledge graph, in this science knowledge graph.
Exactly.
Mhm.
Also, what researchers often do when they write a paper, basically each scientific paper contains a section relationship with the state of the art. Yeah, so there you basically describe other approaches which are similar or address the same research problem. And many papers already contain basically small tabular comparisons where you already organize and categorize maybe your work and juxtapose it with other approaches. And that can be easily fed into the open research knowledge graph. Also, there are in science actually a special type of scientific articles which are survey or review articles, and these survey and review articles already organize the knowledge for a certain research question in a very specific field, and often contain such tabular comparisons or tabular overviews of the work in this field. And that's a bit what we want to facilitate with the open research knowledge graph. So we actually want to build also an approach where you can basically write such survey and review articles using the open research knowledge graph. You basically create a description and add paper and describe contributions from different papers addressing a certain research question, and you can build a comparison. And then we want to also allow to generate basically such a survey and review article so that you can also publish it as a PDF document in the end. The disadvantage of these PDF documents is they are static. Yeah, so once such a review or survey is published, you cannot easily change it. And there's also no incentive to do that. Actually, for the next 2, 3 years, no one else will then publish a survey or review in that field because a large part of the research is maybe covered. While in the open research knowledge graph, you can basically incrementally also advance this and add more descriptions and revise and refine it. It also doesn't only represent the perspective on one particular researcher or a small group of researchers, but others can collaborate in revising basically this comparative view of answers for a certain research question there.
Yeah, so not having this to define the schema up front must be very, so the flexibility of the knowledge graph must be very convenient in scientific publications.
And it's a requirement because science evolves relatively quickly, so you cannot always a priori define an ontology, basically. So it needs to be done on the go. And there are some examples like OpenStreetMaps, for example. They manage this very well, where there is, of course, a bit of a scaffold schema, but you can add all kinds of spatial objects to OpenStreetMaps. Yeah, and people were coming up with like adding trash bins, for example, or bicycle ways, or it was used for catastrophe rescue missions. So OpenStreetMaps has also a very flexible data model where the schema basically can evolve over time. The more certain people are using certain properties and values, the more the schema basically advances. And a similar approach we follow in the open research knowledge graph, so that for new research contribution, you can basically also then define new properties very easily by just typing them basically. You get suggestions from existing and predefined ones, which have others already used, but if you need a new property, it's just a matter of entering the name of it, and then you can define new properties and classes very easily.
So in this kinds of networks, we usually have the problem of information credibility and trust. Do you think the science knowledge graph, just by its nature, will be self-maintaining in this sense?
I hope so. That's our vision, but of course we also envision um, information scientists, librarians to be involved to help curating these knowledge graphs. Um, and of course, we need to implement, we currently don't have this yet, but also measures for assessing the credibility of certain information. For example, whether a certain article was peer reviewed, then maybe the description of this contribution has a higher credibility than publications which were not yet peer reviewed, or also integrating this peer review process maybe into the knowledge graph, that people can discuss individual claims or statements in the knowledge graph and can add whether they agree to that or whether they have a different view on this topic. And these kind of discussions or debates will then also show which parts of the knowledge graph are relatively stable and undebated, and which parts require more discussion and maybe revision later on.
So you said that this automated approach of gathering the data from papers, it's pretty hard to do. So what do you think, if we're a bit optimistic and thinking a step ahead, how would we do that in the future, in like 5 or 10 years? How would we gather this knowledge? I think the manual approach is probably not the vision here, right? Or at least not to be the only approach.
I don't know. Like if you look at OpenStreetMaps, yeah, so they managed with a relatively manual approach to create a map of the world, right? And similarly, Wikipedia. Maybe in the beginning, people would also have said it's never possible that volunteers write articles and in the end create an encyclopedia in 200 languages. And OpenStreetMaps, there were other companies who invested billions basically in acquiring such spatial map data, and a community of volunteers has created a similarly rich source of spatial data and information. So that's why I'm not so skeptic about a manual approach actually, because to return to this example of the base reproduction rate, yeah, I told you there are 30 studies there, and if you look at epidemiologists all over the world, basically there are probably hundreds, maybe even thousands of research groups in the world who are interested in getting the answer to this research question. And often they all have to read those papers in order to be able to answer this question. So if one does the work of representing that in the open research knowledge graph, it maybe takes a few hours, but you save hundreds of hours of other researchers. Yeah. So in the end, it saves a lot of time. It sounds maybe like it's an additional investment, but in the end, it will be a huge time saver. I would say research can become 20-30% more efficient if we can use such a knowledge graph. Our question or our task now is to convince the researchers that it's really a time saver, and to give maybe those who invest a bit of time, that the effort distribution is a bit differently. Yeah, right now everybody has to invest a certain amount of hours into gaining overview of the state of the art. When using such an open research knowledge graph, basically one or a small group of people has maybe to invest a bit more than what they are currently investing, but in exchange, these other 90% will benefit from the work such a small group has done. And we hope that, for example, by making the contributors more visible in the open research knowledge graph, that they will gain additional reputation by this, maybe also being able to publish it as a formally published article and getting citations for their work. These will be all incentives. So that's why I'm not so skeptic that the manual approach doesn't work. But I agree. We want to automatize it as much as possible. I just know that it is not possible with the current techniques. Maybe when we have more training data, we can automatize more. But first, we need to get the training data, and for that, we need this manual crowdsourcing.
Yeah, that's fair enough. Listen, so about the exploration of this knowledge graph. So if I'm a researcher and I'm looking for information on a specific topic, what what interfaces will I be having to explore it? Will it be a semantic search Google like where I can ask natural language questions which are translated to Sparkle or GQL queries or whatever? Will I be able to visually navigate through this science knowledge graph?
Absolutely. So our ultimate goal is, of course, to answer natural language questions and to translate them into queries on the knowledge graph. For now, the main interface is basically research comparison tables, which we generate. For example, different algorithms or different assessments of the basic
Mhm.
reproduction number or different climate models for modeling the climate change, and then you can compare them according to different characteristics. And since it's such a tabular and structured representation, we can also create all kinds of visualizations, for example, bar charts or pie charts on top of that.
Mhm.
So we now integrated also visualization framework where you basically can, with a few clicks, create a visualization on top of the results for a certain research question. um, we also have a graph view, so you can actually look at the graph itself, and how the different contributions are connected with each other. Um, and we want to provide such natural language interfaces in the future, but that's something we still are working on.
Let's think a few years ahead and assume that we're able to actually represent scientific knowledge as you plan it in your project in a few years, let's say five
Mhm.
years or 10 years. So do you think we will be able one day to represent it with such a small semantic gap that we will be able to reason over this data and maybe even deduce new knowledge and new kind
Absolutely, yeah.
of.
That's also one aim we have in mind, of course, that we can discover what kind of research approaches, maybe where are gaps, where would more research be interesting and required. Currently, research is driven a lot by the intuition of the researchers. Yeah, you have a certain idea of what you think might make sense to investigate, but I definitely think we can advance and accelerate the scientific progress if machines can assist us and tell us, here might make sense to maybe check out this or that particular approach. Yeah, and that can be done much easier if you have such a knowledge graph, and you can basically analyze different approaches. You can see which ones are successful or what results they render under which conditions, and then you can create suggestions what should be maybe tested out in the future, and what could be promising directions. Also, another very important aspect is interdisciplinarity. Often, scientific breakthroughs come by combining knowledge from different disciplines.
Mhm.
Um, so, for example, also now if you look at epidemiology, we know that aerosols, for example, are extremely important for the breaking infection chains of the virus pandemic. And aerosol research is, for example, something which is done in climate research or also in engineering, but not maybe so much in epidemiology and virology. So we actually need to bridge between these different communities. And that's much easier when you can basically get results for a certain research question quickly, and you don't have to invest months or even years of your time in getting an overview of the state of the art. But you can basically in such an open research knowledge graph get an overview of approaches for a certain research question, even if it's in another field than in yours. You can identify who are maybe the colleagues to talk to later on. Yeah, and this is currently often a bit based on the serendipity effect. You maybe have read an article of someone, or you know someone, or you work at the same university. But with such a research knowledge graph, it could become much more systematic and maybe less error prone.
Mhm. So yeah, that's actually a very interesting point because research is based on other research and on assumptions and on findings from research that has been made before. So if let's say there is the Newton laws and then the relativity theory comes and my research was based on the previous findings, right? And they are maybe either disproven or only working on specific circumstances now, then there is a whole chain of research that gets affected by that, right? That you can trace back with knowledge graph.
Yeah, I think these connections between research, of course, they are partially represented by citation networks already, like you cite other papers in research, and but it's often not so clear what the citation actually means. Are you building on top of the research? Is it just distantly related? Is it something you like or you don't like? This is all not really clear. Maybe it's described in the text, but it's extremely difficult again to figure that out. And also, the text is often written actually of scientific publications, not always in the way that it's best understood by others. It's optimized for passing the peer review process. So, certain things you actually try to hide in your paper because you don't want peer reviewers to stumble upon it or to discover it quickly. So, you maybe some negative results or negative aspects of your approach are a bit hidden in some way or not even discussed. And that makes it also very, very difficult actually for the scientific progress. And such an open research knowledge graph could represent the viewpoints of different people. So of course we want the researchers to add their own perspective or add their own contributions to the graph, but then other researchers can augment that and can say, yeah, here I think this approach doesn't have has certain other characteristics, and in this discussion, in the end, you have basically a systematic structure to steer this kind of discussion and debate about scientific progress.
Yeah, it sounds like a lot has to change in the culture of research. So
Mm.
maybe even the criteria, how papers and publications get accepted, or how how do you change this culture? How do you make people think of this bigger target towards collective intelligence rather than focusing on their own contribution?
I think actually researchers understand. So to most of the researchers we talk, they quickly agree. They say that's exactly what we need. Of course, the challenge is getting them to contribute, to add this 10, 15 minutes overhead of describing their research in the open research knowledge graph. And we have a bit the chicken and egg problem here. Yeah. So before the open research knowledge graph doesn't contain a lot of a critical mass of content, before that point, it's also not very attractive right now to add your research because there are not so many people yet looking at it. That's why we, for example, work on this approach of generating review publications out of the graph, because then you have something which you can put into the traditional publication life cycle, and you build on the one hand the open research knowledge graph. On the other hand, you also have a publication, a traditional publication, which can be cited. Yeah, but I think also like we need to, as researchers, to make us aware with what kind of antique methods we are working. Because if you look in other domains, if you look, for example, in e-commerce, yeah, 20, 30 years ago, mail order catalogs were the way to organize commerce. Basically, you could order products from, there was in Germany Quelle and Otto catalog, or in US JC Penney and Macy's had these catalogs. And now, of course, you would not order anything from such a catalog if you would get it by mail as a PDF document once a year, and then everything would be static for 1 year. But we are now used to use platforms like Amazon, like eBay, like Idealo, where we have real-time information about products and prices and reviews. Yeah, and that's a completely different way how e-commerce is done nowadays in the digital world. In research, basically, we work with the same methods. We basically use the same methods as in the beginning of science, like 400 or 500 years ago, when the first journals appeared. They were publishing the same static articles as we do now. Of course, now we can get them as PDF documents, but we need to advance that. And you can see that not only in the e-commerce domain, but also I mentioned Wikipedia already. I mentioned maps. For example, 20, 30 years ago, you had to buy a street map when you were going on holiday or when you wanted to navigate somewhere. There were a whole industry of publishing houses focusing on producing these kind of maps and selling them every year updated. Nowadays, you use a navigation system which guides you from A to B, right? So we see in many areas where we have a lot of information that there were digital born approaches which are developed and which exploit these new possibilities we have in the digital world. Unfortunately, in science, we don't have much of that yet. We basically are already very happy when we can get the PDF or the articles now as PDF documents. But if you compare this to the progress in other domains, it's still quite outdated and makes scientific work very cumbersome and challenging.
But why is that? I mean, you would expect it maybe from some industries like the legal industry and so on to be a bit to not be
Conservative.
compliant with the newest innovations. But how come does
I
the
think the reason is
research?
the incentive systems in research. The incentive systems, you are measured in the number of publications you publish and in the citations which your publications attract. Yeah, and that basically carves this in a way in stone, makes it very difficult to change. And
Mhm.
that's why we also, with the Open Research Knowledge Graph, we don't want to abolish traditional publications. We want to augment them. In the beginning, of course, I hope in the future you can generate your publication directly out of such a knowledge graph. So you start with the knowledge graph first, and not after you wrote your article. And that can be then also quite a improvement in the scientific method. There are actually also some other approaches like Jupyter notebooks, for example, which are now used, where you basically describe a certain procedure or analysis you do in kind of a software, in a software script, in a Python script, for example, but at the same time you write also your article in the notebook. So, and Jupyter notebooks are a nice way of also creating a new digital method basically for a new type of digital scientific publications. Yeah,
So the open research knowledge graph will be accessible not only to researchers, but maybe even for everyone else, right?
exactly.
So we have in a few cases we have this problem in society, the with trust in scientific results, right? So we have this about climate change. There's people who argue with that, and we have the same thing about COVID-19 and many other things where people just disagree, maybe because of lack of scientific knowledge, maybe because of lack of trust into just believing in results they don't understand. Do you think that this open research knowledge graph might help for the community and society to get closer to science and to
Yeah,
by creating this transparency actually to yeah make people
absolutely.
act
Yeah.
on things?
Also, you get an overview, for example, when I get back to our example of the basic reproduction number. Yeah, so there were 31 studies which we found. Probably there are even more. And of course, there are some which assume the basic reproduction number to be just 1 or 6 or 7. Yeah, these are a bit outliers. But in this comparative view, you can basically see that there are very few studies which have such an extreme view on this particular research question. The majority of them is in the area of three, between 3 and 4. Yeah, and that's why we came to the conclusion that the basic reproduction number is around 3 for the COVID-19. Now it might be a bit higher with a new mutation, maybe 3.5. But that you can much more easily see basically when you see the research in such a comparative overview. and then you can see which ones are maybe the more outlier opinions, or and what is the standard and the consensus in the community. But of course, we also need, I think, sometimes a bit divergent views of things, and they should be discussed and should be analyzed. Yeah, so it's not should not be the aim, of course, to completely um, standardize everything, but at least to bring more transparency and a better overview. And then it's also more difficult for people to dig out one particular study and maybe claim that what is written in this particular study is the scientific consensus on a certain research topic. But you can easily then see in such a transparent graph view that there are a lot of other studies coming to different conclusions.
Probably for the first time in the history of humanity, we'll be able to represent scientific knowledge in a machine readable way and process it like if it was in a database and query it and apply algorithms to work and reason on that. So what do you think, what will that change for humanity if we will be able to do that?
Yeah, I think it will accelerate scientific progress in a way. It will help us maybe faster to master challenges like the pandemic we are facing now. Climate change is another one, resource efficiency, mobility. We have so many challenges, but it's actually relatively slow sometimes, the progress we make, and we need faster progress there. So that will be one result. Another result will be also that maybe science is a bit more efficient in a way, because my impression is we are inventing often the wheel several times and doing the same things, sometimes with different words. Um, Also, we often don't exactly know what is the state of the art, yeah, and then there's maybe also not always an easy way to measure a progress. So I think it could improve the scientific method a bit, because you have a more scaffold how to measure the contribution and the impact different approaches make, and increase also the efficiency and of science in general. So we spend huge amount of money. It's actually 2 trillion worldwide per year. So not million, not billion, but trillion per year. And I would say that 20-30% of that money is not well invested right now, because we use such antique methods in a way. And yeah, there is a lot of redundancy, duplication, inefficiencies in the knowledge flows in science and technology.
So how far away are we from this intelligent open research knowledge graph?
That's a good question. So basically, the Open Research Knowledge Graph is working and functional, so everybody can use it yet. But of course, we right now we have, I don't know, 5-6 thousand contributions in there, 1,000 research problems. This is like, of course, not at all yet covering a significant part of research in science, with millions of publications being published every year. So we now need to see how can we get researchers in a large scale really on board in using that tool. And yeah, we need to see how much we need to tweak the usability, for example, create these incentives for researchers to contribute and to create this knowledge. Of course, there are also many open questions how to deal with the evolution or the discourse in the open research knowledge graph. These are things, reputation, which we haven't implemented yet, where we need to invest also a lot more development effort. So I would say it's probably a task for the next decade to solve this problem.
Yeah,
But
sounds great.
on the positive side, I think already one particular description of approaches for one particular research problem already saves a lot of time. So we don't need to have this established for whole science to be effective, but already one description of a research approach in the open research knowledge graph helps other peer researchers to be more efficient and effective. Yeah, so that's why it's also can work incrementally, and we don't have to wait until it's fully functioning and all researchers worldwide use it. It's already helpful if small communities are starting to use it, and then this will already have a a small impact or medium-sized impact, and the big impact will come the more the penetration of this technique goes. Maybe there are also other approaches which might evolve. There is also now a lot of discussion on research data management, organizing research data. Um, in a way, the open research knowledge graph is unique. As I said, there are a lot of bibliographic knowledge graphs out there. Microsoft Academic builds a knowledge graph, and Springer Nature has one science SciGraph, I think it's called, but this focuses more on bibliographic information. That's something we don't have in mind so much. Also, Wikidata contains quite a lot of research information. Meanwhile, we of course also want to integrate and link with these other knowledge graph projects. So it's maybe also not just a single monolithic knowledge graph, but maybe there will be several ones which are integrated and where there are interfaces which focus on different aspects. And of course, also in some scientific disciplines, there are already efforts to build also structured knowledge bases, basically. For example, in the area of AI and machine learning, there's Papers with Code, a project driven forward by Facebook AI, which has a very nice description of a lot of machine learning and AI approaches there and creates ladder boards. So this is, of course, also a very relevant resource and very aligned with the vision we have in the ORKG. And we actually want to integrate and link both knowledge bases tightly in the future. Aspect which is also important is actually the transfer or the use of scientific knowledge, which we didn't talk yet so much, because of course, also especially with the collaboration with companies, I think it's very important that companies can benefit from research, and such an open research knowledge graph of course also allows company to quicker identify what is the state of the art in a certain field and how to build on top of that, and which approaches maybe to follow, what characteristics have certain approaches. So that can be also an additional aspect which is quite important to, in a way, improve the transition from research from academia to research and innovation in industry,
Do you
which
think we
often
will?
nowadays works via brains. You basically have people who, after they did their PhD, they then start a job in a company, right? But of course, also companies can read scientific papers, but such a more structured semantic representation can help companies and organizations also to benefit more directly, maybe from the knowledge generated in academia.
Do you think we will be having something like subscriptions to the parts of the knowledge graphs enriched by specific research institutions?
Yeah.
So the company can just pay for per month for having always new results on a specific research field.
Yeah, that's our open research knowledge graph actually will be open, so we will not make companies pay for accessing it. So this will be open, as the many scientific articles should be open. Unfortunately, not all of them are open, but there is a big discussion also on open access to scientific publications. Yeah, but I guess there are maybe additional services like certain analytics you could perform on top, or gaining new insights, which might also, yeah, companies might be interesting to pay for in order to get such value-added services. But the core of our open research knowledge graph will always be open.